Alright, it's filming.
All right. Gentlemen, today I'll be teaching you about the Euclidean algorithm, which you can use to find the greatest common divisor of two numbers. All right. First, I'm going to write out the official math notation of the algorithm here. So if we let a and b be integers, that's what that means, they're integers, with a greater than or equal to b, which is greater than 0, then there will exist q1 and r1, which are also integers, such that a equals eq1 plus r1. Can you guys all hear me?
Yeah.
Where 0 is less than or equal to r1, which is less than or equal to b. Nice of you to show up, Peter. Thank you for coming on time. If R1 is your remainder here, so you can think of a and b as a equals b times q plus a remainder. This is pretty much just division backwards. If R1 is not equal to 0, in other words, if there is a remainder, then you take it down another step and you say b equals r1 q2 plus r2. And pretty much you keep going until the remainder equals 0. And when you do that, actually, say you get your last remainder here, r of n equals 0, then r n minus 1, or the remainder before it, is going to be your greatest common divisor of the two numbers. Go on to a new board here. Alright, now we're going to do an example problem here. So we're going to find the greatest common divisor of 803 and 154. That's how we write greatest common divisor. Just put it in parentheses with the comma. Alright, so by the formula here, we start off with 803 equals 154 times q1 plus r1. Alright, now 154 goes into 803 how many times? Can you tell me, Mitch?
4.
4 is not correct. It's 5.
Close.
So here's what we write. We write 803 equals 154 times 5 plus R1. Okay, can anyone tell me what R1 is? Peter, Mr. Lake over here?
Can't help you.
Okay. Now what if I remind you that R1 is going to equal 803 minus 154 times 5?
13.
No.
Why is it
Again, wrong. It's actually 33.
It's 30, yeah.
Okay. R1 equals 33. Okay. Now we're going to keep going here. So Mitch, can you tell me what the number here is going to be when we move down?
Yeah, that's 154.
Okay, good, good. So we write 154 equals 33 times q2 plus r2. Can anyone tell me how many times 33 goes into 154? Well, the answer there, Mitch, is
It's
4.
4.
Yeah. Okay, so we write 154 equals 33 times 4. And I'm not going to wait for you guys to figure it out, so it's 22. I'm going to write 22. And then we carry that down. All right, so we say 33 is equal to 22 times 1 plus 11. And then we go again and we say 22 is equal to 11 times 2, and then plus 0. Now since we ended it here at 0, our greatest common divisor is going to be the last remainder, which is 11. There you go. The Euclidean algorithm, boys.
That's pretty cool.
Yeah.